So here we're going to discuss the concept of what limits are finding for us. And the limits are the groundwork for all of calculus, in that in calculus, we're never really looking at a specific point. We look at what's happening as we get close to a specific point. And by close, we mean infinitesimally close, so close that it doesn't seem like that the distance between where you're at and that point is so small, it might as well be zero. But we have to keep in mind we're never actually at that point, just extremely close to it. So with limits, there are three types of limits. There are two of them that are called one-sided limits. And a one-sided limit is easiest to explain graphically here. So here I have a graph of a function. It doesn't really matter what the algebraic equation is. This is just a function. And as you can see, it does pass the vertical line test. If I were to look at when our x value is b, I can see there's a discontinuity here. And I want to look and see what is my function value. In other words, what are the y values approaching as I get closer, as the x's get closer to b from the left. So the easiest way to do this, is to take something. I like football, so I'm using a football. And I'm just starting over on the left-hand side of my graph. And if the football follows along the curve of the function here, as I move closer and closer to b, so here I see 5, then 4, my y value is now 3, now 2, well, about 2.5, 2.25, 2.1. And what it looks like is as I'm approaching from the left-hand side, my y values are approaching a 2. This open dot at b actually has no impact on my limit at all, because this open dot is just saying there's no y value for x equals b here at this specific moment when x equals b. But we're only getting close to it, and I can get as close as I want to it, but never reach b for an x value, and my y values then are approaching 2 from the left-hand side. In terms of notation, when we write this, we use the abbreviation LIM for limit. However, we never say lim. Whenever we see the abbreviation, we still say the limit of the function. And then below the LIM, we say what variable we have control over, the independent variable, what it's approaching. So we're saying that x is approaching the b, and then this superscript negative sign is saying x is approaching b from the left. So we read this as the limit of f as x approaches b from the left. And we already said that this is 2. And so this is a left-hand limit. If I wanted to talk about having x approach b from the right-hand side, I would have the limit of f as x approaches b from the right. So again, if now I'm looking to see what happens to my y values as I approach from the right-hand side of b. Y is 0, y is -0.5, -1, -1.5, -1.75, -1.9. And here, the y's are approaching -2. And again, I don't care what happens at b. It's as we get close to, the x's get close to b, what happens to the y's. And this is a right-hand limit. The third type of limit is kind of a combination of a left-hand and a right-hand limit. This is saying what happens if I approach a certain x value from both sides. So if I approach b, in which case we don't put a superscript with what x is approaching. So we have the limit of f as x approaches b. And with no superscript, we're implying we want to approach from the left and right side. So we already said approaching from the left, the y values are getting closer and closer to 2. Approaching from the right, the y values are getting closer and closer to -2. Well, in this case, This is where two-handed limits have to be kind of taken with a grain of salt. Two-handed limits can only exist if the left-hand limit equals the right-hand limit. So here, the left-hand limit is not equal to the right-hand limit. So for x approaching b, the limit does not exist. And again, this is a two-hand or two-sided limit. To get a better idea of what happens with a two-sided limit, let's take a look at as x is approaching a. So if we first find our left-hand limit, of f as x approaches a from the left, we're coming from the left-hand side, y is 1, 2, 3, 4, 5, 5.5, 5 3/4. It's looking like 6. Then finding the limit as x approaches a from the right of f, we have 3, 4, 5, 5.5, 5 3/4. That's looking like 6. Well, now, because the left and right hand limits are the same, they're equal to each other, the two-sided limit, the limit of f as x approaches a, superscript implies it's from both sides, would also be 6.